Okay, so if you wanted to graph acceleration, we've talked about graphing velocity. We've got our physical image for what a constant velocity graph looks like. And we get that line for velocity by graphing what against what? Time on the x, position on the y, because it's literally distance over time. What could you graph that would give you acceleration? So velocity is the change in position over the change in time, and graphing change in position on the y, change in time on the x, gives you a line that shows velocity. What would show acceleration? Pardon? Yes, graphing velocity on the y and time on the x. So when you graph velocity against time, you show acceleration. Oh, you all have that in your notes. Oh. Yeah, I guess that's the downside. Okay, so you all know the next part. What shows the acceleration in that graph? The slope of the line. Yeah, the slope of the line is going to show you acceleration. And it's the same thing. If you look at the formula for slope, that's exactly what you're doing when you graph velocity against time. Okay, now, this is simple, it's straightforward. We've got a fake graph here that shows velocity on the y, time on the x. So that line is the velocity of some object. The slope of that line is the acceleration. So in what sections of that line is the acceleration positive? How about so we're saying that the slope of the line is equal to the acceleration. So whenever the slope of the line is positive, acceleration will be positive, right? Okay. So from A to B, is the acceleration positive? Yes. From B to C, what's the acceleration? 0. And it's badly drawn. But yeah, there's a point at the top of that little hill where you have a 0 slope. Acceleration is 0 there. Your velocity is therefore constant. Your velocity is constant. Remember, velocity on this graph is 0 when you get to the x-axis. Okay, from C to D, is the acceleration positive or negative? Negative. All right, D to E? 0. The acceleration is 0. Is the velocity 0? No. It's slow. They're approaching 0, but they're not 0. From E to F, acceleration? Positive or negative? Positive. Acceleration, yes. Yeah, we do that. Okay, and we'll skip F to G. G to H, again, you see what? Acceleration zeros, but the velocity is not 0. Okay. I to J, acceleration? Negative. Now, let's ask the other question. How does this relate to speeding up and slowing down? Because that's the other question. From A to B, we said the acceleration is positive. Is that object speeding up or slowing down? It's speeding up. Because velocity is doing what? The magnitude of the velocity is doing what? It's increasing. We're going from 0, we're going away from 0 with the magnitude of our velocity. From C to D, we said that the acceleration was negative. Is the object speeding up or slowing down? Slowing down, because the velocity is approaching 0. This is easy, right? Good. Let's make it more complicated. Okay. So, in your own notes, jot down in which sections of that line is the acceleration positive. Okay. Somebody in black or gray? Okay, Morley, go for it. Which sections of that line have positive acceleration? A to B, yes. E to F, is the slope of the line from E to F a positive slope or a negative slope? So is the acceleration positive or negative? negative. Okay, so A to B has a positive acceleration. Where's the other instance of positive acceleration, Chuck? G to H. So we have two sections of line that have a positive slope, that have positive acceleration. From A to B, is that object speeding up or slowing down? Speeding up. The velocity is moving away from zero. The magnitude of the velocity is increasing. From G to F, is that vehicle slowing down or speeding up? It's slowing down. How do you know that, Caleb? Because what? Its position is negative, yes. Whether it's actually going backwards or not, we don't know. But its position is negative. In that section from G to H, velocity is approaching zero. When velocity is approaching zero, what's happening? You're slowing down. The reason we can have a positive acceleration while an object slows down is because remember that velocity is a vector quantity. We can have positive velocity, we can have negative velocity, and they all relate to position. So if we call